All right, so we have Algebra 2, Unit 6, Lesson 7, Finding Unknown Coordinates on a Circle. So we're still going to be using the unit circle. Um, Oftentimes in mathematics, or involving mechanics or engineering, and things are rotating in circular fashions, the unit circle is applied. So 7.1, notice and wonder big and small. So what I want you guys to do is I want you to spend the next couple minutes just trying to figure out um, what you notice about circle. I guess we'll call this circle ABC or triangle ABC, right? Because they have them labeled based upon their vertices. And then versus triangle DEF involving with that circle. And my hint for you is is that. Okay, so give yourself a minute. Go ahead and pause, and I'll give you time to figure that one out. All right, so pause, try to figure it out. Okay, so hopefully you paused and you tried to figure out what you noticed. They did give you coordinates, right? They gave you coordinates for that point right there. What do you think the coordinate is going to be for D, point D? So go ahead and pause and try to figure that out. Okay, so hopefully you spent some time and you reflected on this. Hopefully you realize that this circle right here is much larger, right? How much larger? So the radius here, right, is 1, but the radius over here is 2. It's 2 times bigger, right? So could you see that being a dilation? So in transformations for geometry, we refer to that as dilations, right? So you add a dilation, all right, by a scale factor, uh, which we denote by k, which is a horrible k. There we go. With a scale factor of 2. So k means scale factor. All right, so what does that mean about the coordinate for d? Well, isn't d's coordinate going to be very much like a's coordinate? But it's basically going to be 2 times greater. That's a 7, a very horrifying 7. And 0.5. So d will be actually the same as a, except you're multiplying by 2 because everything is twice as far away because the radius is now 2. So dilations are just applied like that. So notice your scale factor, algebra-wise, is just a multiplier. All right, it's just doubling in this situation. If you notice anything else that I didn't talk about, um, and you think it's significant enough, or you thought of it differently, definitely let me know. I would like to share that out with you guys in a video. All right, moving on. So a clock coordinates 7.2. So here's a clock face. Cool. And let's see here. The length of the minute hand is 5 inches. Okay. Ooh, context. So from here to here, that would be 5 inches. So notice how I'm already applying the context. So context matters, especially if you think about the last example we were doing. Um, the scale factor of 2, right, was definitely context. So this is context. This is probably a scale factor of 5. So we're starting at 0, 0, which I marked right here, right, the origin, if you will, and determine the coordinates of the end of the minute hand at the following times. So part A I will do, part B I will do, part C is for you. Okay, you have to do part C. All right. Part A, let's do that one. So 45 minutes after the hour. 45 minutes. So right here, that'd be part A, right? That's 45 minutes. after the hour. Um, explain your reasoning. So, does everybody agree that this is 5 comma 0, right? This is 0 comma 5, because again, the minute hand is 5 inches long. So A is just going to be at -5 comma 0. So that'd be your answer for part A. Okay. And then, of course, if you think about it, down here is what? X is 0, but your Y is now -5. Ooh, speaking of X and Y, remember when we're talking about unit circles, X and Y is the same as saying, so cosine is your X of whatever your angle is, and sine is your Y value of whatever your angle is, or theta. Okay? That means angle or theta. All right, that's its Greek name, theta. All right, so let's begin. 10 minutes after the hour. This one's a bit tricky, and let me go ahead and use green. Okay, so I'm going to do green or some kind of gross color. I don't know what color that is for B. All right, so this part is 10 minutes after the hour, so that's part B. This one's difficult, isn't it? Because you're just thinking like, what value is that? Definitely a decimal. So instead of confusing myself with decimals and trying to approximate things, which could be a nightmare, I'm going to go ahead and use angles in terms of the unit circle. So if I do that, one thing, if you remember the unit circle, we split them up by what, 15 degrees. So does everybody agree that this would be, uh, let's see, 30 degrees? It looks like 30 degrees. What do you guys think? What do you guys think the degree is of 10 minutes after the hour for that minute hand? So um, we have, oops, sorry, there we go. So does everybody agree that we have a third of 90 degrees, right? Because here's your 90 degrees, and you have 3 parts in there between the 90 degrees, so it's a third of 90 degrees. And remember, in geometry, pi is 180 degrees, right? So if you have a third of 90 degrees, right, because half of 180 is 90, right? So 90 degrees. So that is 90 degrees, okay? Um, that's going to be pi over 6, right? The denominators are being multiplied, right? All right, so what is that in terms of degrees? If you want to, you can convert it, but that'd be 30 degrees, right? Just because pi is 180, right? All right, so we have pi sixth. All right, and I want to use that. Now we care about the location for it, and we know that the scale factor is still 5 inches, right? So our coordinate for B is going to be cosine, and let me go ahead and make some room here because I'm going to add a little something something to this. We have our scale factor, right, of 5, cosine of pi over 6, right, which is that angle that we need, comma 5, because our scale factor, times sine of pi over 6. So that would actually be your coordinate for B. If you guys plug that into your calculator, and I highly recommend that you try this, you should get, I'm trying to remember, 4.4. Yeah, you should get 4.4 and then 2.5 for that value. So go ahead and try part C. It's very similar to part B. All right, you will be using cosine and sine. I will not go over it. This is definitely for you to make sure that you challenge yourself, okay? All right, moving on to number 2. Now they're just changing the context. Do you guys see this? They're just changing the context. Everything else, question-wise, is the same. Like you still just that's all that changed. Everything else is the same. So instead of negative 5 comma 0, it's going to be negative 15 comma 0. Instead of what, 5 cosine pi 6, it's going to be 15 cosine pi over 6 comma 15 sine of pi over 6. So notice they're just applying the scale factor. You go ahead and do C, okay? And I want you to know it's going to be very, very similar to number 1C, except your scale factor, right, is going to get changed. So go ahead and do that one. All right, number 3. Number 3, this is going to be an interesting one. Okay, so at a certain time, the minute hand 00, approximately 7. Ooh, okay, 7.5 comma 7.5. So let me draw this to kind of show you what's happening. What they're asking you is, can I draw a circle? Ah, that's not too bad. And they say 7.5 comma 7.5. That would be right around there, right? 7.5 comma 7.5. And they're asking, how long is the minute hand clock if each grid is 1 inch by 1 inch? Oh, okay. So we all agree that we can also use triangles inside circles, right? In fact, that's where the 7.5 comma 7.5 comes from. Well, they're just asking for the radius at this point, which is also your hypotenuse. So you could use Pythagorean theorem to get your answer. You have 7.5 squared and another 7.5 squared. And what does that give you? All right, but don't forget, that's going to be, um, let me make sure we set it up correctly so you know what we have to do. We have to square root still, right? So let's see, here we go. So r squared, right? So what do you get? Go ahead and try to find r, the value for r. So hopefully you found 112.5 equals r squared. How to get rid of a square? Go ahead and do that. All right, and if you did that, you should get r equals 10.6 something, right? So 10.6 inches is the context that we're maintaining here. So context matters. All right, so that should be the length of your minute hand. Now, is there another way to do this? Yeah, yeah, there is. 7 comma or 7.5 comma 7.5. That right there is actually a 45-degree angle. All right, that's a 45-degree angle. 45 degrees. Okay, so this is another way you could have done it. I'm just showing you the other way you could have done it using, but this is geometry, right? We used geometry here. All right. Um, or we could try actual trig if you want. So let's see here. So this is the unit circle that we're going to think about. 45 degrees, which is half of 90, right? So half of 90, right? That's 90, which is just pi over 4. So 45 degrees is really just pi over 4. Um, now, on the unit circle, that would be zero point 0.7. So let me show you guys here. That's a horrible circle, I know. But just using the unit circle, 45 degrees will give us 0 0.7 comma 0 0.7, okay, for the unit circle. Now, we ended up going to 7.5. So what times 0 0.7 is going to give us a 7.5? All right. So your scale factor, what's 7.5 divided by 0.7? you should get 10.7. All right, which means that the minute hand clock is 10.7. So notice how there's two different ways of getting your answer, but now the real question is who's more exact? Hmm. So I'll leave that up to you to think about. All right, 7.3, around a Ferris wheel. All right, so there's this nice little applet on the website for Kendall Hunt math curriculum. Yeah, I think if you create a student account, they might give you the applet for this unit, which is actually pretty cool. It has a scroll wheel and everything. I wish I can show it to you, but it messes up my recording. All right, here we go. So we have a center of a Ferris wheel at 40 feet off the ground. All right, so we have our 40. Uh, the radius of the Ferris wheel is 30. The center of the Ferris wheel. Okay, so good thing I'm being very inquisitive. That means we got 40 feet right here. And then they say the radius is 30 feet. Okay, good for them to let us know. Um, Now they say calculate how high off the ground point P is when the Ferris wheel rotates counterclockwise. All right, so starting at 0 radians. This is starting at 0, so that's 0 radians, otherwise known as 0 degrees in this situation. So they're talking about radians. All right, so what's the height in pi half radian, or not pi half, pi twelfths, right? So we got our 40 feet, right, plus our scale factor, which is 30 degrees, and they're asking about height. They don't care about left or right. So do we care about the x value? No, we just care about the y value. Y is sine, right? So 30 degrees or 30 feet, right, for our scale factor, times sine of pi twelfths, and that's all in feet. Go ahead and try to figure that in the calculator and see what you get. Okay, so hopefully you type this in the calculator, and you should get about 48 feet. All right, let's try part B. We have, again, our 40 feet, right? And our scale factor is still 30, right? Our Ferris wheel is still 30 feet in radius times, I don't know why I put the parentheses there. Got parentheses happy. There we go. Times sine of pi halves, right? Which is our angle. And that's in feet. What do you get? All right, and you should get 70 feet. I want you to go ahead and try part C and part D. But notice how they're just talking about the height, and that's the y. So they only care about the sine of theta. They don't really necessarily care about to the left or to the right. They're just focused on sine because they're worried about height. Okay. All right. So as you go around on the Ferris wheel, at which possible positions would you be 60 feet off the ground? So there are several positions in where you could be 60 feet off the ground. Um, we know that we are here at 40. So let me try to get the highlighter going. All right, so 60 feet off the ground. There are I think 2 points, maybe more. Nah, I feel like there's only 2 points. All right, so let's double check. Let's see. I want to make sure I only give you one, and then you have to find the other. So does everybody agree that half of 30 is what, 15? But we want 20. So it's going to be somewhere here and somewhere here. because you need at least 40 plus 20, right, in order to get you 60 feet. Does that make sense? So somewhere around here and here. I'm trying to refine my idea. Now, what would give us that? Hmm. Which positions? Positions. 50 to 60. Hmm. Tell you what. I want this. I don't want to steal this one from you. This is actually a really good one. So go ahead and try to figure out exactly where that would be. I think that's a really healthy one for you to do. Definitely use your calculator. All right. You could always try something similar to what we did. Um, we know that we got what, 70 feet here, right, for that one. So try playing with this value right there to see what you get as close to 60. And there's two possible radians that you can pick to get you 60 feet. All right, so that's my hint. It's a really good one. That's a really good question for you guys to. I don't want to steal that from you. All right, so have a beautiful day. If you have any questions, please email me and I'll respond in a video. All right, have a good day. Bye.